Right here we're looking at an example of a decay function. Now it's a decay function because the base here is 1/2, so that's between 0 and 1, so it's a decay function. Now what we're going to do is plot points and see what our graph looks like. Now if I plug in -2 for 1/2, since I have a negative exponent here, I'm going to end up flipping this so that we get 2 over 1 squared, so we end up with 4. Okay, and I'm going to do the same thing for the -1. So if I have 1/2 to the -1, if I flip this, I end up with 2 over 1 to the first power, so I end up with 2. Now, I'm going to go ahead and do 1/2 to the 0 power. Remember, anything to the 0 power is 1. Okay, and then if I take 1/2 to the first power, I end up with 1/2. And then 1/2 squared, remember I had to square the top, so that'd be 1. Square the bottom, be 4. So I end up with 1/4. Okay, so that's our y values, or our range for this. Now, so let's go ahead and plot. So from this, we go over 2, 1, 2, up 4, 1, 2, 3, 4. And then at -1 would be at 2. The -1 would be 0. Then at 1 would be 1/2. And then 1/4. And then we'd get closer and closer to the x-axis. Okay, so as we're drawing our graph here, try to draw a smooth curve. And with this is going to get closer and closer to the x-axis, but won't actually cross it. And remember, when it gets the line that it gets closer and closer, that would actually be our asymptote. Okay, but to draw we draw from left to right a smooth curve that begins just above, okay, the x-axis and passes through the points plotted and moves up to the left. Okay, now if you'll notice that we crossed the y-axis at 1, so that's our y-intercept. Okay, as the values of x approach -infinity, we're going this way on the x-axis, what's happening to our graph? It's getting larger and larger and larger as far as the value. So it's approaching positive infinity. Positive infinity. As the values of x approach positive and the value of the function approaches. Now, on this one, we're saying as the x's get more positive, what's happening, we're getting closer and closer to 0 on the y-axis. So as the function is decreasing on the intervals from -infinity to positive infinity. So what that means is as we start here and come down, we're getting smaller and smaller. Now we will never cross 0. Now I'm going to do some calculations down here to find the average rate of change. Remember, it's going to be y2 minus y1 over x2 minus x1. Okay, y2 is going to be 1/4 minus 4. Okay, because that's our y2. x1 is 2. x2 is 2 minus a -2. So we'll end up being plus here for 4 on the bottom. Okay, now the fraction, remember to subtract a fraction and a whole number, okay, we got to get the same denominator, put it over 1. So I'm going to have 4 over 1, multiply this by 4. So we end up with 1/4 minus 16 over 4. Okay, and then it's all over 4. So when we take the difference here, we end up with 15 over 4, -15 over 4 over 4. Okay, so we're dividing a whole number, a fraction by a whole number, so we're going to actually flip this. So when we do that and multiply, so we end up with -15/4 times 1 over 4. So we end up with -15 over 16. And then if we change that to a decimal, we end up with -0.94. Now the slope is negative because of the way we're tilted and coming down. So that's why we end up with a negative slope here, our average rate of change. Alright, here we're going to graph another one. Now, what I first suggest you do is establish what your asymptote is, because we're not going to plot. We will plot, and we'll find the average rate of change here, but we don't need all those points. What we need is -2 and 2, and then the range that goes with it. okay, if there's nothing added to or subtracted from this, our asymptote is going to be right here. So it'll never cross the x-axis. Okay, so I'm just going to jot that out a little bit. So that's our asymptote, so it'll never cross that. So if we cross that line, we did something wrong. Alright, so let's go ahead and come up, basically I'm going to come up with 2 points. I'm going to come up with what happens at -2 and at 2. Now our intercept here would still be similar because of when we put 0 in here, we end up with 1. Now notice our graph here is a little, our how it's labeled and distributed. We have 4 here, so it's a little bit off as far as a little bit different. It's not a one-to-one relationship. But anyway, let's look at this. So we take 1/4, take it to the -2 power. Flip this, and that becomes positive. So we're going to square that, and we get 16. So when we're at -2, our graph's at -16. So we come over to the -2. Now this one's in 1 is our unit. So 1, 2, and then these are 4s. So that's 4, 8, 12, 16 would be there. Okay, now when I put in 2 for it, I'm going to take 1/4 and I'm going to square it, so I'm going to end up with 1/16. So when we're at 2, we're at 1/16, which is going to be somewhere in here. Alright, now it's going to be a little bit harder to estimate here, but basically our graph would flatten out down here, and then we'd cross here and then go up. Now my graph's a little bit off, so I'll redraw it, but we're going to get a look to it like this. And so that gives us an idea of what's happening with our growth function. But again, establish your asymptote, okay, and then draw your graph with the 2 points. Now the average rate of change, to come up with it, we're going to use these points. So our second x and our second y, so it's going to be 1/16 minus 16 over, because remember it's y2. Alright, remember it's y2 minus y1 over x2 minus x1. So then it's going to be 2 minus 2, -2. So it's going to end up being 4 again here. We want to get the same denominator here. So we're going to multiply this by 16. So we get 256. We get 1/16 minus 256 over 16 over 4. Take the difference here on the top part, and we end up with 255 negative over 16 over 4. Okay, we want to get the same denominator. Well, no, we don't need the same denominator. I'm sorry. We're dividing a whole fraction by a whole number, so we're going to take this and flip it and multiply. Okay, so when we do that, we end up with 1/4 times all this. So we end up with negative 255 over 64 as our average rate of change. Here we have an example where we have A. Now A just has to be, can't be 0. But let's see what happens. So we want to plot a point. So we're going to put in 0 for x. So we end up, if we do that, we end up with -2. We end up with 1 because of anything to 0 power is 1. So we end up with 3/4 to 0 power. So this ends up being 1. So we end up with -2 here. Alright, then if we put in 1 for our x, we end up with -2 times 3/4. So we're going to, I'm going to go ahead and reduce. 2 goes into itself once, goes in here twice. So we end up with 3/2 negative 3/2 as our points here. Okay, then we're gonna plot these 2 points, and then we're going to draw our curve. Alright, we've plotted these, and now what we're going to do is then from right to left draw a curve that begins just below the x-axis. Okay, so our x-axis is our intercept, and what's going to happen is we're not going to cross it. I'm not an intercept, it's our asymptote. and then we'll have a graph that comes out something like this and moves down. Basically what's happened, remember from transformations, this has reflected our graph, the negative. And we'll look at another example in the next video.